All right, number 8. The number of atoms in 9.0 gram of aluminum is the same as the number of atoms in how many grams of magnesium? All right, now, so I'm going to pretend that I'm an average student. And as an average student, I would be like, okay, all right, I can see the grams. All right, I can see the grams. So I should know, like I said in the previous question, I should know the number of moles. I should. And by the way, let me go ahead, write down the molar mass from the periodic table for aluminum. It is 26.98. So close to 27. That means 9 grams, it's approximately 0.33 moles of aluminum. Okay, now, like I said, you need to know approximation because by knowing how to approximate, you've got more numbers to work with and it will definitely help you make sense. Okay? So it'll be like, oh yeah, 0.33 moles. Now, the next question to come in right here is this. Do we use the Avogadro's number because it sets the number of atoms, right? Do we go to the individuals? Well, the answer is you could use it, but you don't have to. And the reason is, if I say this, okay, if I say there are two high schools, okay, there are two high schools, okay, the number of people in high school A is the same as the number of people in high school B. Does it matter how we group them, right? If I say, oh, there are 20 pairs of students from 20 pairs of students from high school A, then how many students are there in the high school B? Well, 20 pairs or 40 because they're the same. So we are talking about quantity, and we have two ways to express quantity right here. You can express quantity in terms of moles, which is in groups, right? Or you can express the number of atoms in terms of its individual count. It doesn't really matter, okay? And we just do whatever that's easy, and that is just stay with moles because we have those head counts in terms of groups already. We don't need to go into individuals. They're the same. They're the same. Now, of course, I'm more than happy to show you the work if you want to. I mean, I will show you the work so that you can compare and contrast. So again, you know the mass of aluminum. Then you can find out the moles of aluminum. Okay. And then what? It sets the same number, right? Not 2 times, not 3 times. It's the same. That means 1 mole of aluminum, every 1 aluminum atom is to 1 mole of magnesium. By the way, make sure you read the elements carefully. Magnesium is Mg, manganese, it's Mn. Don't confuse those two. And then what about the mass over here? Magnesium mass, it's 24.305 grams per mole. So 24.305 grams of magnesium for 1 mole of magnesium. And that's the answer. That's the answer, right? 9 divided by 26.982. Yeah, it's 0.333555. So right at our approximation. And then times 24.305, because that is the same number of moles, then that should be 8.11, no, just 8.1 because 2 sig figs only, grams of magnesium. That's it. All right, that's it. Now, what if somebody says, oh, I thought we need to use the Avogadro's number. So let me go ahead and expand this calculation if you are considering the use of Avogadro's number. So it'd be like, oh yeah, I should get the actual number. Okay, the actual number of individuals. Sure. Okay. And then you would still multiply by the same ratio because they're 1 to 1, right? But then before you use the molar mass of magnesium, well, it's the molar mass. You got to know the moles before you know the mass. So we say, oh yeah, we have to bring back the individual amount of magnesium to groups of magnesium. And then we multiply by the molar mass. So what you're seeing here, and what I said, it's kind of unnecessary to use the Avogadro's number is because they just cancel each other out. And why? Well, we're talking about the same thing. It doesn't matter how you group the people, as long as you group them the same way, then the count will be the same. And since we are dealing with mass, it will be more convenient to work with numbers in groups, right? Just like if you want to go to the grocery store and buy some apples, it would be much better to say, oh, how many pounds of apples are there? Oh, there are 5 pounds of apples. Okay. You don't want to use ounces. You don't want to count individuals because they don't help. They just don't help because your unit price is dollars per pound. Okay. So that's how you figure out that, oh, it's 8.1. So A is the answer. A is the answer for this question.